Welcome to this Visual PFAS tutorial where we'll explore how to create radial diagrams which help to evaluate PFAS trends. In this tutorial, we'll be using the airport demo data file included in the Visual PFAS installation package. We'll be creating radial diagrams that show concentrations for various sulfonates as explained in detail in the Visual PFAS user guide. If you are not sure how to create a project, import your dataset, or create a base map, please refer to the earlier tutorial videos in this series. In these earlier videos, we had created our demo project, imported the project database, and created the initial base map. In this tutorial on radial diagrams, we're starting with the same demo project already open in Visual PFAS. So to start out, let's move the cursor to the navigation bar at the top of the page and click on Radial Diagrams. And then in the drop-down menu, we'll select New. In the pop-up window, you can name your radial diagram anything you want. In my case, I'll be naming it PFSAs, which stand for perfluorinated sulfonates. Visual PFAS will automatically choose the RD properties subfolder under the project folder where it'll be saved. Once the radial diagram is named, you can click Save. A radial diagram properties file will then open, giving us the ability to edit the diagram to our liking. The General tab will be opened first. In here, you can edit the number of axes and which chemicals will be shown on the diagram by clicking on the pencil icon. In the window, it'll show the total number of axes on the diagram, followed by the currently selected axis. Here, axis 1 is selected. Under that, we can assign a chemical. Here I will be assigning FHXSA to axis 1. We can then insert another axis before or after the currently selected axis. This will automatically adjust the angle of the axes. I will go ahead and configure the remaining axes by assigning PFAS to axis 2. PFHXS to axis 3, and PFBS to axis 4. You can then select the number of series you would like to display on the diagrams by clicking on the pencil icon here. In this window, you can select which set of data you would like to use as a reference series, and then the set of data that you would like to use to analyze specifically. In this case, I will use the single right-facing triangle to select source A as my reference series. And the 2023 February 15th dataset as my monitoring events. You can then select the number of locations you would like to analyze by clicking on the pencil icon here. You can choose specific subgroups such as shallow or deep wells. This filtering of the well list can help with projects where there are too many wells to choose from. You can either choose one well by clicking the single right-facing triangle, or choose all the wells by clicking the double right-facing triangles. Today, I will select all monitoring wells. Now in the General tab, you can also change the axis color and title colors. Finally, the non-detect option can be selected using the drop-down menu at the bottom of the window. This option tells Visual PFAS how to plot concentration results for samples where a chemical was not detected. The option includes plotting the radial diagram line at the minimum axis range at a value equal to 1/2 of the detection limit, or at the detection limit itself. In this case, I'll be selecting the MDL, which represents the detection limit, as my non-detect option. If you would like to view a different monitoring well, you can use the drop-down menu above the diagram to select a different monitoring well. There are many more options that can be changed in the different tabs at the top of the window. If you would like more details on that, please refer to the user guide. Once we are done in the General tab, we will go into the Chemicals tab. At the top, you'll notice that the chemical FHXSA is the currently selected axis. It is important to note that changes made will only occur to this currently selected axis. Note that according to the project database imported in an earlier tutorial video, Visual PFAS has set the default concentration units of FHXSA to be micrograms per liter. In this window, we can change the scale to a log scale. And then we'll change the minimum concentration range to 0.01 micrograms per liter and a maximum concentration range to 1000 micrograms per milliliter. There is also an option to check what the minimum and maximum concentrations are for this chemical in the project database by clicking Check Database. This will bring up an input window that shows the ranges of detected concentrations and also the detection limits for non-detect results, as you can see here. The database window that automatically opens reports the minimum and maximum ranges of detected concentrations, and also the minimum and maximum detection limits for non-detect results for the currently selected chemical. Now let's press OK without making any further changes to the ranges here. Since the changes only apply to the currently selected axis, you'll need to repeat this process for the 3 remaining axes. Let's make these changes for PFAS, and you can see in the radial diagram legend how the axes change as we change the scale and the minimum and maximum ranges. Now let's make these changes for the PFHXS axis and finally the PFBS axis. In the Series tab, I'll select Source A and change the series line to be dotted and black for clarity. I'll also change the weight to increase visibility. I'll then return to the selected series and change it to the 2023 February 15th series. And I'll change the series line to be blue. Now I'll select the Draw Fill checkbox in the series fill properties and change the color to beige. And I'll adjust the opacity to be 50%. Opacity is the opposite of transparency. So an opacity of 100% means that the fill has 0 transparency, and an opacity of 50% means that the fill has 50% transparency. Now in the non-detect symbol section, I'll increase the size of the symbol and change the shape to a triangle. And I'll also change the fill color of the exceedance symbol to red and change the line color to black. Now Visual PFAS has a built-in autosave function, but it's a good practice to manually save your files once you are finished configuring your radial diagrams. This can be done by moving your cursor to the navigation bar at the top of the page and clicking on Radial Diagrams, and then selecting Save PFAS. Now let's click Windows in the navigation bar and select Base Map to return to the Base Map window. In the Map Overlay panel, you can select the Radial Diagram tab and click on Add, and then select the radial diagram file you have just created. To ensure that the diagrams are visible, click on the row of the radial diagram file, and this will enable the Edit button. And then you can click the Edit button to increase the size of the radial diagram to 2000 map units for visibility. And this value represents the updated length of the radial diagram axes. We can then see our radial diagrams are overlapping, and the original base map location symbols are still visible. To resolve this issue, you can go into the Map Properties panel and select the Symbols tab, and then unselect the checkbox for the symbols. In Visual PFAS, we have the option to offset radial diagrams at adjacent well locations where the diagrams are overlapping. Here, I'll be moving monitoring well 5. I'll do this first by clicking on the digitize icon in the navigation panel. The cursor will then change to a plus symbol, and we will be able to move the cursor to the desired location of the diagram. We can then click at that location on the map where you'd like the center of the radial diagram to move. A window will then appear with the newly digitized coordinates. You can click on OK, which saves these coordinates to the clipboard in Windows. Now we can click on the selection icon in the navigation panel to return to the default cursor. Now to offset the overlapping monitoring well 5, you must select Windows in the navigation bar and select Properties in the drop-down menu. In the Map tab in the Radial Diagram Properties window, we'll click on the pencil icon and select Monitoring Well 5 using the right-facing triangle. And then we will click Enter Offset Coordinates and select the Monitoring Well 5 row. And then we'll click on Paste Clipboard Coordinates. Once we are ready, we'll click Apply. And then finally, we'll change the offset symbol size to 150 map units. Now, before we exit, we will save our changes once more. And then using the window option in the navigation bar and selecting base map, we can return to the base map. When the radial diagrams are completed, the final map can be exported. To export the map, go to the Base Map tab. And in the drop-down menu, select Export Map. And then you can select the format of the file and the location of the file. Here, I'll save the file as a JPEG onto my desktop and name it Demo Airport RD. Finally, we will also export the radial diagram legend as a PNG file using the Windows option in the navigation bar and selecting Properties. and then using the radial diagram option in the navigation bar to select Export Legend. In this window, we can select where the file will be saved as well as the format it will be saved in. I will name my file Demo Airport RD Legend and save it as a PNG. We can also export the radial diagrams itself as a DXF file by selecting the Base Map tab. And then in the drop-down menu, I'll select Export Radial Diagrams. This file can then be imported into different programs such as CAD, GID, or Surfer as separate layers. And just like that, you have created your radial diagrams in Visual PFAS. In the next video, I'll show you how to create stacked bar maps. Thank you.